Everyone watching this has probably spent some time at the ocean at some point in your life. The sandy beaches, the peace of the ocean, the crashing waves. But what even are ocean waves, and how do they work? Waves are caused by a number of things and contain massive amounts of energy. In fact, just 2% of the total energy of ocean waves could be used to power the entire world. There are essentially three types of waves: wind-driven waves, tidal waves, and tsunamis. Wind-driven waves form as wind passes over the surface of the water. Pretty simple. Energy from the motion of the air molecules in the wind is transferred to the top layer of the water through friction and pressure. These transfers of energy cause disturbances in the water that is carried through the water. One thing interesting about ocean waves is that the water isn't actually moving. Rather, it's the wave that moves through the water, in general. This means that as a wave moves through the water itself essentially moves up and down, reacting to the wave energy moving through it. So, wind can cause waves through friction and pressure, but there's also another hidden force to certain waves: gravity. Tidal waves are not massive tsunami-like waves like you may be thinking. These are actually just large waves that move across our planet. The gravitational forces of the Earth, Sun, and Moon affect how the water on the Earth behaves. The Moon has the greatest effect on waves as it moves around the Earth. As the Moon moves, it causes oceans to swell on either side of the Earth, or the side closest to the Moon and furthest from the Moon. As the Earth rotates, tides around the world go in and out, as we all probably know. The actual mechanics of this might surprise you, though. The bulge of the water on the Earth stays consistent with the location of the Moon, and it's actually the movement of the Earth that greatly affects tides going in and out. This gives the appearance of high and low tides when in actuality it's the Earth that's moving, not the water. The last type of waves to discuss are abnormal in nature. Tsunami waves are large, powerful waves caused by geological disturbances like earthquakes, landslides, or volcanic eruptions. Tsunamis are generally very large simply due to their nature and formation. Now that we've gone through the different types of waves, we need to understand a little bit more about the physics of these waves. When ocean waves meet, generally one of three things happen. Sometimes they don't interfere, rather they just add together momentarily, called superposition. If one wave was traveling in one diagonal direction and another in the opposite, the point where they met in the middle of the x would be the height of both of the waves added together. In other cases, waves can cause destructive interference, which occurs when two waves collide with the crest of one wave meeting the other. This is essentially identical to how electronic waves work too, thinking of it as positive and negative. When a positive crest meets a negative valley, they add up to zero. They cancel out. The last possible interaction of the waves is constructive interference, which occurs when two waves collide and the crests align. When this happens, the waves add together to become one massive wave. Finally, when a wave hits a shore or beach, in most cases, the land can oppose the force of the wave and causes it to expend all of its energy. This causes the wave to come crashing into shore, bringing us full circle back to the peaceful beaches we all know and love. So that's how waves work, through wind, gravity, and sometimes volcanoes.